Hello, today we're going to talk about a very simple training schematic. This is what I would consider a level 1 training board. So I have in my training center possessions, I have a level 1, level 2, and level 3. So level 1 is kind of a basic layout. It has a DIN rail to keep the components in place. That way nothing's loose other than my overload contactor. This came out of an old isolated unit, but it worked because it has a manual reset and a manual trip for testing purposes. So this is a basic layout. What we have different here on this particular one is I have a circuit breaker on this board. It's only because that was this way I can control the power on and off. And the schematic I'm about to show you does not have that. We have terminal blocks all numbered. There's numbers on both sides of these that are identical that you may or may not be able to tell, but they're jumpers between the terminals. That's why they're marked the same number. There's a terminal jumper in between those, and also on these two, 9 and 10, or 9. There are jumpers between those, so we can hook up multiple wires without having to double tap on one side of the terminal block. Here is the schematic that we're going to talk about today. We have our power coming in, going to terminal 4. Wire is going to leave terminal 4 to terminal 6. Terminal 6 to get to the jumpers there. Terminal 6 is going to come down to our common of our relay, general purpose relay. After the common is going to go through a normally open set of contacts, waiting for the control relay coil to close. Once the common and contacts close, that voltage is going to allow to go to terminal 10. From terminal 10, it's going to go to my motor. Providing my overloads are not open, they're normally reset and wired in and drawn in as normally closed. They're going to go back to terminal 9. Terminal 9, following it back, goes back to terminal 1. Terminal 1 goes back to my neutral. After 6, when 6 also has a power, 6 will come down and it will power up my time delay relay coil. My time delay relay has an adjustable setting on it. For now I set it higher, so I'm going to take you step by step, taking measurements according to the schematic. Once the time delay relay actually times out, my neutral, because it is a coil, it is an induced load, is going to come back to terminal 9, which is going to come back to my neutral. Terminal 6 is also going to power up my normally open time delay relay contact. Once the time delay gets finished timing out, my normally open is going to close. It's going to energize my relay, my control relay, my multi-purpose relay. And again, it's an induced load. So it's going to go back to 9, allowing it to come back to my neutral. Once my relay is received power, my armature closes. This contact is going to close, allowing my motor to start, providing my overloads are not on. I am now going to turn the motor on and demonstrate step by step where these terminals are according to the schematic. Right now, my motor has not started. Reason being, my time delay relay has not finished timing out to allow this contact to close. Now, how do we know that? The first thing we want to start with our test leads. You can do your test leads in your left hand or your right hand, whichever one you're more comfortable. Some people use the positive terminal here, my red terminal, and my dominant hand, which I'm right-handed, and some people use their non-dominated hand for their common terminal. The common terminal on AC systems, if you can change the polarity of your terminals, positive or common, on AC circuits, but not on DC circuits. DC circuits are polarity sensitive, which you have positive goes to positive, negative goes to negative. AC circuits are not that prone, but for the training purposes, I'm going to keep both my test leads in my common and my positive wires. Another thing you want to do is keep your hands closer to the edge of the wire leads instead of on towards the end. We don't want to put our hands too close to the ends of the leads here so we don't have to get possible shock. I'm going to put my common terminal into terminal 1, according to the schematic is my neutral. I'm going to check terminal 4 is shown input voltage. If I check terminal 6, that has input voltage. Now I have one wire coming into terminal 6, and I have 2 blue wires up top coming out, and I have 1 yellow wire coming out. My yellow wire coming out is going to go into my time delay relay. That is going to be my common. So if I follow this wire around to my yellow relay, I am now applying voltage. If I follow this wire around, which is going to be from my time delay coil, my coil is receiving voltage. If I follow my next wire around, which is going to go to my common terminal on my relay block, my common terminal is also receiving power. Now up top here, I have a brown wire coming out the common into terminal 10, and then from terminal 10, I have this other wire here that goes to my motor. Terminal 10 is not receiving power, and my relay contacts are still open, so they're not applying power. So my time delay is already initiated. It has started. It is set up for just over 2 minutes, just so I can get this training purposes. So we verified, according to our schematic, power is coming into 4. Power is leaving 4. We verified power to 6. We verified power to 6 is going to our common on our time delay relay. We verified our time delay coil is energized, so now it's going to start timing. And we verified power is going to my common of my general purpose relay. We have power here, but we have no power here. This is the brown wire going up to terminal 10. My fan motor just started, so now we can check it again. We know we had power to 6. We had power to our coil, our time delay relay. We had power to our common. We have power to our common on a relay. We have power leaving our coil. Our contacts will normally open has switched to closed because my coil is now energized. Once my coil energized, my contacts have closed and my fan motor is operating. You see here my fan motor is operating. Now, what happens if you're working on, we'll present, assume this is a 3-phase motor, not a single fan motor out of a computer system. I'm going to apply my meter leads to my second wire leaving the motor on my overload block. I'm going to apply it back to my common terminal. Common terminal 1, according to my schematic, I'm on my motor overloads. My fan's running normal. All of a sudden, one of the overloads, we either have a single phase loss on my 3-phase power, I have a bad wire, something caused the overloads to trip. Comes along and trips. My neutral terminal has now changed state. I have voltage going into my motor. Because my motor is not inducing any current, that voltage is going back through my common wire to my overloads. Common. If you follow the overloads, I have a white wire here. If I'm going to move my test lead over one more, I don't have any power. So what I'm doing is I'm sending voltage from my motor, because I'm not drawing and inducing any of the current. As the voltage is applied, it's going straight through the windings. No inducing, so it's going straight through a wire, no different than a pair of wires, going straight to my overload contacts. This is one way you can actually troubleshoot your overloads. If you're not sure if your overloads were tripped or not, check one portion leaving directly from your motor or if it's a starter application, and check and see if you're actually receiving nominal voltage. If you're receiving nominal voltage to one of your overloads, that means your overloads are tripped. If I resolve the problem and I trip them, you can see my meter's gone away and I no longer have an issue. One of the things that you saw on here was I'm using my test leads are interchangeable. These are silicone leads. I can apply them into my meters. I do have alligator clips. These make it easy and convenient to be able to attach onto wires and to have your hands free, and also keeping your fingers far enough away from the system here. Okay, so now I'm going to demonstrate changing the relay state over from a normally open set to a normally closed set, and I'm going to go through the troubleshooting process one more time. Okay, now I changed the state on my relays from normally open to normally closed. So as soon as I close my circuit breaker, allowing power to come in, it's going to start my circuit here. I'm going to adjust my time delay a little bit higher now so I can do some troubleshooting without it coming on in the midst of all that. On previous videos, I have the time delay relays I discussed. The particular one I have set over 250 seconds. I can adjust this when I'm ready to lower it down, and it'll actually trigger on once the timing portion has started. Once I apply power to the coil of my relay, I can start that. My schematic is the same here. The only difference is now this is closed and this is open. So I basically move the wires from this point back to that point. Okay, I'm going to go ahead and apply power again. My fan motor immediately started up this time. Taking my test leads, starting from the beginning, I have voltage coming in. I have voltage to terminal 6. I have voltage to my common, or my coil for my time delay relay. I have voltage to the common of the time delay. I have voltage going into my common of my relay. And I do not have voltage to my relay. My relay itself is not receiving coil voltage. And my motor is receiving power, and I'm not receiving any voltage to my leg because my fan motor is running, my overloads are not tripped. So start this from the beginning. Try to hold this up here and see if I can get, my last lead didn't work the last time I tried this. So we're going to go from 4 we don't want to work today. We'll go from 1 to 6, and you have power. So I have 1 to 6, I'm having power. Receiving power to my common terminal. So I'm receiving power here back to 6. I'm going to check my coil there. I have voltage. So my common on my time delay relay has voltage. If I check on the output of my common time delay relay, which I can check here, my output of my time delay relay is now one terminal. My time delay relay is showing no power. This is my normally closed contact on my time delay relay, but I have no wires connected to it. If I move it over 1, I don't have power. Okay, I don't have power, no power going to my relay here. tough to do with one hand. So I verified I have no power leaving my time delay relay to my coil. So I have no power leaving here to my coil. And my motor, I verified, is receiving power. Okay, this is on a normally closed contact. I'm going to change this, adjust this time delay relay down slowly. Now my time delay has energized, allowing for the time that I had previously set up. My coil is now energized. My contacts are not energized. My motor is not energized. So the time delay relay had timed out on the time delay off to where it did not allow me to have my motor because I changed this lead to that location. Okay, the last thing I want to talk about again that I may not have talked about in previous videos, I'm going to go ahead and reset my timer, reset my time delay so I get my fan motor to come back on. So an overload block is basically taking your neutral from your motor. It can be a single phase motor. It can be a three-phase motor where you might have breaking the neutral from a contactor. The difference between a contactor and a starter is only having an overload block. These particular overload blocks have bimetal in them. They are rated, this one is rated as an E69. If I was to pull up the manufacturer's specification numbers, it would tell me what amperage this particular fan motor would to trip, or motor itself would trip based on these metals. What current would trip it, and what range would the low point and high point. Usually they'll give you a specific range, and electrical loss is always 10%. This particular one, again, is only used here for training purposes, so I can manually create an issue where I can trip off the motor. You can measure current or measure voltage, and I can reset it. So by the overload block, all we're doing is inducing and breaking the neutral leg, breaking a circuit. Remember, on a circuit, we have to have a complete path. If we have power going in, but we break it through this overload block, we don't have anything going back out. Overload blocks are different, depends on the application. This particular one was mounted at one time to the back of a plate to a set of contacts on an old train system that has been removed since then. We put VFDs in and don't need the overload blocks to control that, because the VFDs have that function internally. And we always want to make sure we have applied power going to our VFD. We're only controlling the signal portion. We're not controlling the voltage. VFDs don't like to have their three-phase power turned on, turned off, on, off, as you would as a contactor. They like to have the three-phase power all the time, and there's a control switch signal that will turn the VFD on or off and turn the motor up or down. Okay, this is a basic layout, some basic troubleshooting of a board here. If you have any questions, contact your instructor. They can answer more questions for you. In my previous videos, I've talked about the time delay relays, or the general purpose relays. I have talked about the time delay relays to where discuss these in more detail, along with some smaller sets. This is an overload block we talked about before. Now, have not talked about it previously. And again, this is a very simple schematic that is used for either refreshers, first times around you want to look at systems, and so forth. Again, thank you for your time. I hope you enjoyed the video.